Dear students, welcome. Today we begin our module on the fundamentals of remote sensing. And this first class is titled What is Remote Sensing and Why is it Important? Before going into the content, let us review the goals set for this session. By the end of this class, you will be able to first define precisely what we mean by remote sensing. Second, identify the essential components that make up a remote sensing system. Third, recognize the historical and current importance of this discipline. And finally, we will introduce the key distinction between passive and active remote sensing. These will be our pillars for today's class. Let us begin with the basic definition. Remote sensing at its core is the science and art of obtaining information about an object or phenomenon without being in direct physical contact with it. In other words, we observe and measure from a distance, as illustrated in the image accompanying this slide. This could be a satellite orbiting the Earth or an unmanned aerial vehicle, commonly known as a drone, flying over a crop field to gather data. The key is the absence of direct contact. To understand how this works, it is necessary to analyze the remote sensing process. This process can be broken down into sequential steps. Let us examine the first three. As shown in the diagram, everything begins with a source of energy. In many cases, especially in passive remote sensing that we will study, this source is the sun, which illuminates the Earth's surface. Then this energy must pass through the atmosphere, where it interacts with it. The atmosphere can scatter or absorb part of the energy, altering it before reaching the target. Once the energy passes through the atmosphere, it reaches the surface and interacts with it. Here we speak of interaction with the Earth's cover, where energy can be reflected, absorbed, or transmitted by different objects and materials, such as vegetation, water, or soil. Continuing with the process as shown in the diagram, once energy has interacted with the surface, the fourth step is that the energy reflected or emitted by the surface is captured by a sensor. This sensor is designed to record electromagnetic energy in different wavelengths. Once recorded, the information undergoes transmission, reception, and processing. Raw data are sent from the platform, for example a satellite, to ground stations where they are received and processed to correct errors, georeference them, and convert them into a usable format such as a digital image. The next stage is interpretation and analysis. Here, specialists and you, as future users, analyze the processed images and data to extract meaningful information and relevant patterns. The information obtained is used to make informed decisions, generate new knowledge, or solve specific problems across a wide range of fields. This is the ultimate goal of remote sensing. Although technologically advanced today, remote sensing has interesting historical roots that predate the digital age. Its beginnings trace back to the early 20th century with rudimentary attempts such as photography from homing pigeons equipped with small cameras, or from hot air balloons. A major boost came from military aerial photography, especially during World War I and World War II, when it was used extensively for terrain reconnaissance and locating enemy positions. The space age, beginning in the mid-20th century, brought the first satellites in the 1960s, such as Sputnik, and more relevant for Earth observation, Tyros-1, the first successful weather satellite. Yet a milestone came in 1972 with the launch of the Landsat program by the United States. This program marks the beginning of the modern era of continuous and systematic observation of Earth from space, with data made available to the global scientific community. We have advanced quite a bit in this first session. Let us continue in the next one.